I'm John Richmond, Sales Director at MarqMetrix. This session will cover the all-in-one Raman advantage over competitive technology such as near-infrared, FTIR, GC, and HPLC, and demonstrate the performance, stability, and uptime of this unique solid-state device. Our host today is Brian Marquardt, MarqMetrix founder and CEO. Brian is a renowned expert in the field of spectroscopy and an industry leader in process Raman. He has over 20 years experience in solving complex measurement challenges and developing process measurement solutions across various industries, including oil and gas, biotech, chemical, and pharmaceutical markets. Brian also works for the University of Washington as Director of the Center for Process Analysis and Control. Brian, thank you for hosting our first session. Before we begin, we want to let our attendees know that this webinar is being recorded for future reference. You will receive a link to the recorded webinar after this session ends. Thank you for attending. Brian, over to you.
All right, thanks, John. Good morning, good afternoon, good evening, depending on where you are. I'd like to thank you all for participating. I'm excited to be hosting this session and telling you about what we do at MarqMetrix and our unique approach to process Raman. Our Q&A, just as a reminder, as John said, our Q&A section of this webinar is going to be open for those who want to submit written questions. I will be answering as many questions as possible at the end of this webinar. So without further ado, let's get started. So I'm going to take you, let's do a little history. First of all, as John mentioned, I've been doing Raman for more than 20 years now, primarily in process, primarily in the application in understanding and measuring in process streams, everywhere from the bottom of the ocean at about 3,500 meters doing Raman in a submarine to we have some opportunities right now to go to the International Space Station. So we'll be, from space to the bottom of the sea soon. And I'd like to talk about sort of why we are where we are. We've done a lot of work in the sampling aspects, which I'll show you today, the interface between laser and sample, which was always the Achilles heel of Raman. It's that sensitivity to focus, which makes it the capability for quantitation. We'll talk a bit about how we started there and how we then morphed into the hardware as we were developing systems and solutions for customers and some of the challenges we had with the hardware that was available that we were buying from other vendors. And it got us to basically to the realization that we need something that's more cost effective, more stable, and basically more robust for the process environment to allow us to put Raman at every point of that will be the theme and what we can talk about today. And it's our word that we use since we started on a white sheet of paper and a pocket full of money was to develop a Raman system. We wanted to make it accessible and affordable so we could put Raman at every place of need. Making it accessible. Our goals are to break through barriers, to advance compositional measurement, to open new markets and opportunities for non-experts to use Raman. My challenge all the time was when we were working with these different companies is that there was a number of people that had scientific knowledge, but we never had the expertise we needed to run the complex systems that we were installing. So there was a lot of training involved. One of our biggest goals here was to take the scientist out of the science and to make this functionally push button capable. You see actually one of our Raman systems here on the bottom right. Here we have, you see it on the bottom right. It's small, simply sits on the bench. In this case, it's flat, but can it also stand on end to sit next to, in this case, a bioreactor. And our goal as a company is to be the market leader in accessible Raman solutions to enable our customers to optimize performance within their business. Just a few basics in Raman. Many of you on the call probably have an understanding of Raman spectroscopy. Functionally, it's a form of non-destructive chemical analysis where we actually use a laser to excite molecules. Those molecules vibrate. We then collect the difference in energy that's generated from those vibrations and take them back into our spectrometer. We diffuse them, or basically diffuse them and detect them, and that is known as the Raman effect. What are some of the advantages? It's incredibly rich compositional information. Every peak describes an actual vibration between two atoms in that molecule, or maybe multiple atoms in that molecule. It's both quantitative, and one of the key differences between some of the other spectroscopies I'll talk about is it has a linear response with concentration. It's non-destructive. There's no sample preparation required, and we'll talk quite a bit about that today with some of our sampling technology. We can measure all sample types: solids, powders, slurries, liquids, gases, and heterogeneous samples especially. We can see both the solid and liquid phase in a mixed system. We have very fast measurement times. For those of you familiar with Raman even 10 years ago, we think in milliseconds now, not even in seconds. And if you know Raman from 20 plus years ago, we don't think of it in minutes or hours any longer. And one of the key components to Raman, and we use it quite often, is working in aqueous systems, is water has a very weak Raman signal. So we're able to work in very high concentration aqueous systems to look at chemical composition. And we'll talk a little bit about that today. So how do we differ? So the way I have a lot of experience with traditional Raman. The challenge was that traditional Raman, and the first thing most people think about when they hear the word Raman is that it's expensive. It's expensive, it's sciencey, it's quite large. It has to install it, it has a difficulty level that's higher than just pulling it out of a box and installing it. And there's some instrument to instrument variability. With MarqMetrix, we started literally with 5 points on that same white sheet of paper underneath accessibility when we decided to start this from our own design. It needed to be priced and used at all points of need, so cost was important to us. As I mentioned earlier, remove the scientist from the science. It needed to be a size where we could place it anywhere. So when we were doing a lot of work, we would always have to park the Raman instrument outside of the hood and cable it in. Much of what we were designing here were for continuous flow reactions, which sort of sparked our need to do development. And so to have the actual reactors in with the reaction was very important to us. So size to be placed anywhere. We wanted to have an out-of-box experience where we could do this at a technician level. And so from box to analysis in minutes, in our case, it takes approximately 10 minutes from opening the boxes to taking your first Raman spectrum. And one of my biggest points was because it was so difficult for us to actually develop solutions for a specific process for one of our customers early on. And then to have that customer have multiple points or multiple places to manufacture with that same process, and having to recalibrate instruments when we were doing it potentially in the United States, Europe, and in Asia. We wanted to have one model for multiple instruments. So calibration transfer was at the top of our list when it came to defining a stable, solid platform from which we can actually do process Raman. And we'll talk a bunch about that right at the end of my presentation today. Our goal is actually to improve and understand the total cost of ownership as well as performance, because our goal is to provide uncompromised performance at an unbeatable cost, which drives value. So at MarqMetrix, we provide Raman hardware with low upfront costs that's easy to install. I mentioned the no scientist. It's factory calibrated. We can use one model against many instruments. And we can also simultaneously remotely operate all of these instruments at scale, whether they be local or whether they be around the world. Our goal is to basically take advantage of that Raman expert or Raman scientist in your company, not at your site, to allow you to do the best Raman throughout the world. On the performance side, reliability is a must for us. It has to be reliable and stable for continuous process analysis. To do that, we've built solid state hardware. There's only one moving part in the entire device. It's functionally just a computer fan. We do system health monitoring. We can basically manage from a network or from a cloud if you want some of the key components of the health of our systems. We provide very reproducible results with excellent sensitivity and range. As I mentioned earlier, it's sized to install at all points of need. I'll discuss that in a moment. And how do we deliver value? What's the return on investment? So Raman spectroscopy is very good to determine high resolution compositional data of molecules. That information provides us compositional understanding. It can also provide us real-time kinetics and thermodynamics. It allows us to improve our development and optimization timescales, improves our process understanding and control. End goals in many cases are to increase product yields through that improved understanding. And one of the biggest ones that we find most often is by taking what we call a real-time video. So I'm doing Raman spectroscopy in real time in my process instead of grabbing a sample from my process and going to a lab. I basically connect that to taking a photograph. If I'm grabbing a sample and I get my response after I get old school, get my film developed, then come back and say something about my process. Versus process Raman, where we're actually taking a real live video and allowing us to see the results in real time and make decisions on the fly. They're truly improve these individual steps to get to either increased product yields or reduced cycle times, which is where we see much of it with our customers in the process space. I'm going to touch lightly on the comparisons of technology. I've highlighted a few things. We'll focus on the Raman side. Just a simple comparison between the vibrational techniques of FTIR, near IR, and Raman. One of the key distinguishing points between Raman, as I mentioned earlier, is we're linear with concentration. We don't have a specific range in which our calibrations are good. We are good from basically our limit of detection up to 100%. It gives us rich, high resolution information. We're also able to basically extend the capability. And we've done over a kilometer in some installations, but in many cases we use several hundred meters of fiber optic to displace the box from the actual sampling point. We don't need to purge. We don't have a functional environmental problem with, for instance, an FTIR. We have water vapor and carbon dioxide, which we have to have a purge. We talk about multiplexing and capabilities. We at MarqMetrix have basically built this and priced this that we don't multiplex, we multi-system. It has a lot of advantages, which I'll talk about in a minute, but the primary advantage is it allows us to do parallel data collection instead of serial data collection. On the installation side, one of the key differentiators with Raman and the way we do Raman with some of our ball probe technology is we have the ability to effectively place probes directly in the process, high pressure, high temperature, high flow, and we're capable of monitoring multi-phase systems. We're not specific to particulates or liquids. We can do mixed systems. And our sample interfaces we'll touch on more today. Some of our flow Raman technology, our touch Raman technology, as well as some of our other probe tech. And sample streams, as I mentioned earlier, we can cover the full range from solids, liquids, slurries, powders, gels, and gases. We can do most all of those with the same exact sampling optic. It's not like we have to have a suite of probes to allow us to do the different things. We can do most all of them with a single probe. So with that, giving a little example here, I'll describe the picture on the right first. This is actually a full API production facility done in a continuous flow. This is actually making an antibiotic in real time and continuous flow. You see two MarqMetrix Raman systems up on the top. It's actually being monitored and run using optimal SyntaQ process integration software. There's a few Raman flow cells located just below the boxes here in the chemistry space. But what we're trying to do with our all-in-one Raman product is give you the opportunity to have measurement at all points. In this case, all reactors or channels in real time. As I mentioned earlier, it's easy to set up and operate. It gives us fast implementation time with minimal process disruption. And we do, in this case, we're doing wireless remote client operation. There's another reactor to the side that's doing the next phase of the API production, which is actually being all controlled from this reactor here. It has low total cost. It's very stable, and it's also very sensitive. As I mentioned, we have different opportunities for process control. We've partnered and we work closely with Optimal SyntaQ. We also provide a software developers kit or an SDK. We've provided to numerous customers to allow them to do custom control and actually drive our all-in-one instrument through their own control software, which is quite easy to do. And as I mentioned earlier, and I'll talk a little bit more about, there's no multiplexing. We believe in parallel versus serial acquisition, and one of the main reasons is in my past in doing multiplex system integration and systems. Multiplexers are great when you feel like you're saving money, but if you're not saving money, what they do is provide a single point of failure. Laser, spectrometer, anything goes wrong, the multiplexer, and you have 0 channels of measurement versus 4 channels or 8 channels or 12 channels. It sounds great when everything's running well, but when something goes wrong, you have absolutely no monitoring capability. So it's one of the reasons why I'm not a fan of multiplexers and why we designed this and priced it to allow us to compete against multiplex systems. Let's talk a little bit about our products. Here's an example of our MarqMetrix all-in-one. I was on a call yesterday and someone was giving me some feedback and said, well, I can't tell if that thing's, 2 feet wide or 1 foot wide or whatnot. You should have a scale. And I apologize, I didn't have a chance to retake this picture. But the scale is, it's approximately 10 inches wide, 10 inches deep, and about 2.5 inches tall. I look at it as, if you've ever taken a science class, it's about the size of a nice chemistry textbook if you stand it on end. You see it there with one of our MarqMetrix ball probe and also our interchangeable fiber head. What do we provide? We provide high performance at no compromise. We focus on what's important, and this entire system has been designed from scratch to basically move the most photons from the laser to the end of that fiber optic and back to our detector. And we do that all. It has an integrated computer, so we can simply network the box and allow us to actually control it from anywhere in the world and provide stable and reproducible results. It's easily integrated, easily sized, it has connectivity, it's software, and it's cost. And we provide a broad product portfolio of probes and sample interfaces to allow us to easily customize it to anyone's process system or application. Give you a little idea. One of our goals I mentioned earlier was to reduce the size and cost. So here's an example of the reduction in size. It's about 30 times smaller than your traditional Raman system. So we see a lot of the point where we need more points of compositional measurement. We make decisions about how many points we need by both our budget as well as the size. We didn't want that to be a limiting factor when what we're trying to do is understand and solve process problems or improve process quality. So our goal was to reduce the size and price so we didn't have to make those decisions. And we improved the performance while doing that, while also reducing the total cost of ownership to provide Raman at every point of need. We'll talk a little bit about how we get into this business. We have a number of patents in this Raman ball probe series of products. What we actually have here is we have a round sapphire spherical lens that we use to interface with our samples, be it flowing samples, static samples. We've also built fiber optic coupling capability with our fiber probe head. It's a high through fiber probe, and as I mentioned earlier, everything was optimized for use with our all-in-one Raman system. You may have seen our probes and our probe heads with other Raman companies. We OEM to most Raman companies our probe technology. We have different classes of probes, performance, process, and flow probe models that have different temperature, pressure, and materials constraints. We have numerous sizes from 1/8 inch, 1/4 inch, 1/2 inch, 1 inch in diameter. We make probes out of a variety of materials to meet our customers' process needs: stainless steel, titanium, alloy. We have an interchangeable probe head with accurate and reproducible probe interface. And just yesterday, we found out we got the patent for our interface. So it allows us for precise alignment of the interchangeable probes. In this case, we're actually looking at our bioprobe. It's autoclavable, sterilizable, made with PG-13 fitting to go directly in your fermenter. And we also have single-use sterile probes also for fermentation and bio-related application. One of our newest products is our Flow Raman. We got a patent for this earlier this year. It allows us to directly connect to any flowing system, whether that be liquid, slurry, or even flowing powders. We've done a lot of flowing powder work recently. We can directly couple that to our fluid flow path. It's simple, it's reproducible. It also takes advantage of our ball probe interface. We can sample, as I mentioned, liquid, slurries, or gases. It's easy to install. You can see in this one on the far right, it's simply 1/8 inch compression fittings. On the other, it's our higher pressure version. We sell the high pressure connecting nuts. And we can work at very different, very high pressures, in this case, 170 bar at 350 C with our process probe. And with our standard probe, it still has pretty good capabilities at 34 bar and 200 degrees C. What we're doing, it's very low dead volumes. So the case, we have about 200 microliters of total internal volume with our standard probe. It was actually designed with some of the work that we're doing in continuous flow reactors. We've seen a lot of application use recently on the downstream side at biotech. We're doing a lot of work in protein characterization and understanding of product yield. We'll talk more about that in our next webinar, which is in June. We also have our newest probe as our new standoff high volume probe. Some of the benefits of this probe are it's adjustable. We can basically adjust focal length on purchase between 8 millimeters and 100 millimeters of standoff. It provides a large beam diameter, which increases our sampling area. And if you do a lot of work with heterogeneous samples, you get an averaging effect with a larger spot size. It allows for effective analysis of samples of varying thickness. Some of the applications we're using them on now are tablet coating, food processing, polymer films, control and process control and understanding. An example on the right, some of the work we're doing is in the fish processing business. That's a salmon fillet that we're actually analyzing in real time. As I mentioned, some of the applications, we're doing some through vial stuff, some window feed framework where we're actually seeing products flowing past behind a window, and also doing tablets next in that same way. On the food side, doing a lot of conveyor belt work, fish, potato chips, and we're looking in blenders or macerators and looking at different materials that are being blended in some pretty aggressive large-scale processing in the food business. On the chemical side, hazardous materials is the biggest one, through vials and containers where we don't actually want to have contact with the sample, where we can look at things in vials, and some of the work we're doing now associated with the challenges we're facing worldwide. Just an overview, a little bit of just a smattering of our probe products. I think I was working with my probe manager the other day, and I think we came up with about 35 different probes that we have. We do a lot of custom probe work specifically for people who have needs that are, dimensional needs, as well as specification needs from, 100 degrees, minus 100 degrees C all the way up to, we've done some work in live oil applications where we're about 400 degrees Fahrenheit and about, 20,000 PSI. Our whole thing at MarqMetrix is we can make the best instruments in the world. We can actually have the best technology in the world, but if we screw up the last millimeter, that's the interface between the hardware and the sample, you basically have a random number generator. So our primary goal is to completely reduce the challenges and the variability that are found by doing Raman spectroscopy due to variability in focus at that point of sampling. And so we do that mainly with our Raman ball probe family of products that allow us to touch, allow us to flow, and allow us to immerse with sampling accuracy that's better than 0.1% RSD. And that's always been our goal. We can't use all the multivariate statistics, machine learning, and AI capabilities if we can't make the same measurement of the same sample, every time, not just twice or 2 or 3 times. Process spectroscopy or process understanding and analysis is all about reproducible measurements 24 hours a day, 365, and that's what allows you to actually, extract the value from the investment that you made in that analysis system. As I mentioned a number of times already, we talk multi-system, not multiplex. Some of the reasons why we do that. Here's an example where I do have a picture with some scale. You see 5 of our devices. We're actually using this in a process application today. 10 inches by about 20 inches tall functionally, and 10 inches deep is 5 systems. It gives us increased flexibility. We can use all channels together. In this case, we're looking at a 5-channel reaction system. When we're done with that, we also have the value of we can distribute the individual process systems throughout the labs. I can go to different places. I can go into different offices. I'm not just connected by as far as my fiber optic connections will go from my system. That gives us the benefits of parallel versus serial analysis. So I can measure I can measure 1, 2, 3, 4, 5 all at the same time, not 1, then 2, then 3, then 4, then 5, and then back to 1. It's much smaller. It's conveniently sized. It's easy to place at point of need. We have multiple system control from one interface, or we can actually interface to them individually. We can integrate network control through Syncue, which is our process control partner. We have no single point of failure. If I have a challenge with a box, a fiber, a probe head, or whatever, I still, in this example, have 4 points of measurement with only 1 point of failure. In a multiplex system, a single point of failure, I have no measurement capability. And then we have competitive multi-unit pricing. I could sell this we could sell this at competitive pricing to other multiplex systems. We've done some work in hazardous area. Someone always asks, well, can I use it in my system? Here's a hazardous area system that's a purge system that allows us to do C1, D1, or C1, D2 hazardous location using our Raman systems. The beauty of the size of our Raman systems is that our enclosed systems are not, they're not huge. This is a 28 by 20 by 8 box, so it can be used at line to go perform your process analysis. We've also built some systems that are IP enclosures, in this case for the food business. As you can see, this is a 30 by 30 by 10 enclosure. This system is functionally as a Raman system. You can see it mounted internally. We have our fiber optic cable running out, and this is actually wash down, pressure wash capable to put Raman in a food processing application. I want to quickly just go through a little bit of data, and then we'll finish with some calibration work. Give you an idea of the spectral range and resolution of our system. Here's a cyclohexane spectrum. This is collected at 100 milliseconds, one average, so there's no averaging. We have 10 acquisitions that are overlaid, and it's dark subtracted looking at the laser at 300 milliwatts. One thing I'd like to point out is we have our spectral range is quite good, about 75 wave numbers to about 3,250 wave numbers. We'll see a little more of that in the next slide. Also notice a very strong CH stretch response. We built this thing from scratch, all the optics, everything else in between, the gratings, and our goal was to make sure that we could use 785 nanometer system and also extract information from the CH stretch region, high resolution, as well as high intensity information, and we did that. And we've had some really interesting work that we're doing with highly fluorescent signals where we're able to use the CH stretch capability to do some really interesting calibration work where we wouldn't be able to do Raman at 785 before. Just another example, just to point out the stability, the reproducibility, and the sensitivity, just a few grabs from around. As I mentioned, there's 10 cyclohexane spectra overlaid. We're looking at the stability and at the cyclohexane peak at 801. A little bit on the reproducibility across a number of the bands, and also the sensitivity out at the CH stretch we see down here below. I'll touch on that a little bit more in the next two slides. I mentioned earlier that water has a really low Raman scatter or Raman signal. So here's our water spectrum. Here's a number of water spectra. Actually, it's us measuring water at 15, 18, 21, all the way to 33 degrees. What we were able to do is make 10 measurements at each temperature, but doing them not at each temperature simultaneously, but going up and down through the range. And what I'd like to point out, as you can see, is that we're looking at the low wave number range. So that starts at about 95 wave numbers out to 170. It's one of our vibrational bands of water, and you can see it makes for a very good thermometer. And the one thing I'd like to point out is the reproducibility we have over those 10 different experiments at those different temperatures. And you can see how uniform and reproducible that was. We take that same information and we go out to the OH stretch. So the OH stretch of water starts at about 3,000 wave numbers. It peaks at about 3,300. You don't usually see this with a 785 nanometer Raman system because the detector is usually blind as we go past 3,000 wave numbers. But here we see the same response and another water peak in its sensitivity to temperature. Also look at not only the sensitivity at that wavelength for water, which is a weak scatter, but also the reproducibility as a function of temperature. Now I'd like to finish with something that we're incredibly proud of. As I mentioned, for us to have process system stability is the key. Nobody wants to maintain, nobody wants to babysit, and you don't want to have to put resources towards maintaining and calibrating systems that are installed in a process. So I'm going to show you data for 60-week calibration study we've done on one of our boxes. This box was built about 18 months ago. It was only calibrated when it was built, and it's never been calibrated since. Why do we find long-term wavelength calibration stability important? Primarily, it reduces the cost of ownership due to the reduced need for recalibration. Continuous operation uninterrupted by daily calibration checks provides value. It's a lower cost of model development and maintenance due to robust performance. If we don't have to worry about calibration, our ability to transfer models globally between instruments becomes something attainable. And also we could build library references used to create robust models and spectral ID engines. I'm going to point out real quickly, these are the 9 Raman peaks positions we're going to measure throughout this experiment. They're from our ASTM standard. And this box actually travels as one of our demo boxes. It goes through TSA, it flies around the world, it gets set up and torn down. And we've looked at this box now for 60 weeks, as I mentioned. Here's the calibration data for 60 weeks. We take 10 cyclohexane spectra every Monday that it's back in the office. We use this data in our calibration accuracy analysis, and you can see the 9 peaks on the left, the mean error reported over the last 60 months across those individual points. This is interesting data, but I'd like this slide better. So that's all 600 spectra from the beginning of our calibration study overlaid. So every spectrum we collected over the last 60 weeks is sitting there, all 600 of them, and you can see the reproducibility at those 9 ASTM points graphically on the right. Our Raman shift error and wave numbers ranges between 0.25 negative and 0.25 positive wave numbers. So that's about 5 times lower than the reported ASTM reference accuracy required. So we're quite proud of this, and this is all due to the solid state manufacture and quality of manufacturing that we build. We're ISO 9001 certified. We got that a year ago in May. And we're quite proud of the quality and the reproducibility of our instruments. Speaking of that, I'd like to look at not just an instrument, but let's look at the last 30 instruments we built and look at the calibration accuracy when they were built. Here we see about the same exact distribution across 30 individual systems that were built. Looking at the same ASTM standards, it's better seen graphically, and we look at the distribution plot. We see about 0.25 negative to 0.25 positive wave numbers in the distribution of our last 30 instruments manufactured. This allows us this calibration stability, along with the reproducibility between instruments that we can manufacture, allows us to actually apply global models to reduce the cost of ownership and implementation for Raman. We're doing this in a healthcare application right now where we have over 30 devices out in the field being run by pharmacy technicians. They don't even know they're doing Raman spectroscopy. We have models. We have 22 calibration models down to 50 parts per million that live in the cloud and our validation services. They basically collect thousands of scans a week against those calibration models, and we basically say if it is or isn't a specific drug at concentration in real time to our cloud-based platform and user interface. And we're able to apply new boxes to that model without them ever seeing a calibration standard or validation standard from that model. They're functionally calibrated at the factory and then put out in the service, and they work just like this. With that, I'll summarize some of our goals and what we've achieved. The goal at MarqMetrix is to make reliable and accessible process Raman systems. I hope I've demonstrated that today. Our goal is to be priced to be installed at all points of compositional need. Let's not make decisions because of the capital on hand. Let's make decisions because of the need we have. Small, efficient, reliable, high performance were our goals with extreme stability. We needed to remove the costly scientists from the science through better hardware. The only way we're going to propagate this technology is if we can reduce the price of acquisition, reduce the price of implementation, which overall reduces the total cost of ownership, and also allows us to realize the value of 99+% uptime, which is our goal. These are not things you should think about. These are things you should put in place and extract information from for 5 to 7 years without having to worry about them. And with that, I'd like to thank you all for your time. I'd like to thank you for participating. As a reminder, we have upcoming webinars. June 24th is session 2 of our series. It's a simple approach to biopharma up and downstream process analysis. And session 3 is July 29th, which is a multidimensional PAT sensor for pharmaceutical development and manufacturing. You can follow us at various points at MarqMetrix on LinkedIn, on Twitter. And if you need more information, please contact John Richmond, our sales director, who's going to speak now, at john@marqmetrix.com. Thank you all for your time, and I'm sorry that I ran a bit late. My apologies.
Thank you very much. Thank you very much, Brian. It was only 5 minutes over, so that was a very good job. As Brian said, we have upcoming webinars. We have a question, Brian, that I'll put to you here, and I'll let you take a go at that. The question is, let's say that we want to install your system directly into our pharmaceutical commercial process manufacturing. What level of extended support do you offer for running feasibility trials, library, or research on products that we want to monitor? For example, For example, we would like to try a few feasibility batches, get confidence on this working, and then go for purchase. We would require you to support us for a few commercial batches and for any new product we want to measure. So that's an open question. Brian, do you want to have a go at that?
Sure. So this goes back to well, let's just say the 12 years prior to MarqMetrix, where all we did was application development and support using Raman spectroscopy. We also offer that at MarqMetrix. We actually are a great partner when it comes to application development. We don't expect you to be an expert on day one, so the best thing we can do is work with you directly to allow you to understand our product, your process, and what the value is between those two. We do that on a consulting relationship if you'd like. John can do some simple demos over a day or two on a sales cycle, but primarily if it's extended or through what your question seems, we would gladly work with you to help you to understand your system, to say what value do we provide and how do we actually work with that through a single problem process and actually carry that on to future products. I hope that answers your question.
And I'll just add to that, Brian, that we also have a number of different examples where we can do things like subscription pricing for a period of time, rental systems if required. So we're able to work with any customer to work on a proof of concept. Okay, I think that finally wraps it up.
John, we have one. Yep. We have one more question.
Oh,
so
sorry.
The question is, some of my GMP regulated clients insist on daily calibration record, even when the instrument stability does not warrant it. How do you address that? So we can do a calibration check. So our ability to go and look at our signal or any sample signal from yesterday, it's more of a calibration validation than it is a recalibration. So we can do calibration validation at any time with your process samples or with a standard, if you will, if you have access to that standard. So we do that. So we do that quite often. We have some of our folks that work in the medical field that do the same thing, and all they do is they start their day with a validation sample, assure that they're validated. And we actually have one customer who's working in the medical field looking at some cancer diagnostic work. For 18 months, they took a morning calibration or calibration validation measurement and then the evening validation measurement. And they stopped doing it after 14 months because they saw exactly what we saw. It moves about a quarter of a wave number plus or minus throughout that 14-month time frame. So it was kind of a nice validation of all the work we were doing also internally. We have one other question, which is the software 21 CFR Part 11 compliant? Yes, when we work with Synteq, our process optimization sort of partner, the software is CFR 2111 compliant. That's correct. It's GMP and CFR 2111 compliant.
And we have complete IQ/OQ documentation and procedures as well for our GMP installations. Okay, I think that will finally wrap it up for today. So thank you to everybody who participated. We welcome your participation and your questions.